Good morning. Welcome to the lecture on biocontrol systems. In this lecture, we will be discussing some example problems in block diagram reduction technique. As we know, this is a very important technique which converts or helps to convert a complicated closed loop system into a open loop system. Let us start with a simple example. We have a closed loop system available in it where multiple transfer functions like G1, G2, G3, G4 and H1 are interconnected in such a way that they are forming a closed loop system. We are supposed to reduce this closed loop system into a simple open loop system like a single block with an input, the same input R of S and the output C of S. So that we can straight away write the relationship between the input and output in terms of a transfer function. Let us use the rules available in it. In reducing a closed loop system, the first point we have to fetch is we have to check whether we have series or parallel blocks available. We have to eliminate those series and parallel blocks first, then solve for the inner feedback systems, then we have to go for the outer feedback system. If you are not straight away having a series or a parallel block, watch for a takeoff point or a summing point to move ahead of a block or behind a block in such a way that we get both the cascade or a parallel system. In the given example, we can find there is a parallel block which is situated here, which can be eliminated with a equivalent single block. So from the rule, if I have a parallel block, I can convert that into a single block based on the, the sign available in the summing point. So eliminating the parallel block, the block diagram can be redrawn as keeping the other blocks as it is and reducing the combination of parallel blocks based on the sign available in the summing point corresponding to those blocks. You will get G2 plus G3 followed by another block which is G4, then connected with a feedback path passing through a feedback transfer function H1. Now the same R of S and the same output is C of S. In block diagram reduction, the sign and the orientation of the signal is very important. Now I can find three blocks are found to be in cascade. These three blocks are found to be in cascade, which can be replaced with a single equivalent block. So I can redraw that the actual block diagram by combining the available cascade blocks. I may end up with a single block G1 into G2 plus G3 into G4 as a single block, and the remaining feedback path is available as it is. Plus minus. Now I can see a possible elimination of a feedback, that to a negative feedback. So this entire block diagram can be returned as a, a single block. We know that if you have if you have a feedback transfer function like g h plus minus r and c, I can write this as g by 1 plus gh. So the same principle is used here, which will give me the forward path transfer function g1 g2 plus g3 into g4 divided by 1 plus g1 g2 plus g3 g4 into the feedback path h1. So now the given closed loop system is being transformed into a simple open loop system. So I can write the transfer function straight away. C of s by R of s is equal to G1, G2, G4 plus G1, G3, G4 by 1 plus G1, G2, G4, H1 plus G1, G3, G4, H1. Okay, we will take another example which seems to be a little complicated comparatively to the previous problem. I can see there is no straightaway availability of any cascade or a parallel block. And also I can find a common signal is being fed back to two summing points. You can see the signal, let us say from a node A, is being taken and passed through H1, reaching the first summing point S1 and the second summing point S2. So I can rearrange this entire block diagram into a form which is available here. So this signal point A is taken and enclosed with the summing point, this one. The same point is again taken, passing through H1, reaches the second, and the summing point which is combined is split into two summing points. You can see it here. A H2 is available here. A H1 is available here. So we can rearrange the given block diagram into its equivalent form for our easy analysis and reduction. Now I can find this part of the block diagram can be eliminated first to get a single block of an elimination of a feedback, the inner loop. So if I eliminate that, that ends up with G2 divided by 1 plus G2H1 since it is a negative feedback. Now I doesn't have any further reduction without any manipulation. So what I will try to do here is I will try to move this node A ahead of this G3. While I am moving, this H1 should not get altered. So based on the rule, I introduce a 1 by G3 in the feedback path passing through H1. Now I can see these two blocks are in cascade after the movement. So if I want to combine them, this will be G2, G3 divided by 1 plus G2 H1. And that combination becomes, forms a feedback inner loop with this particular formation feedback of H2 available there. That can be eliminated by having a equivalent block like G2 G3 divided by 1 plus G2 H1 plus G2 G3 H2. Now I can see these two are in cascade, so I can multiply them, followed by this feedback H1 into H1 divided by G3. So this is G1. I can combine them. So the first I will write the series or cascade block elimination G1, G2, G3 divided by 1 plus G2 H1 plus G2 G3 H2. Now this is the forward path transfer function. Then we will have a feedback path transfer function H1 by G3. So I will have a transfer function G1, G2, G3 divided by 1 plus G2 H1 plus G2 G3 H2 plus the forward path again G1 G2 H3 I think G3 into H1 by G3. So this G3 G3 gets cancelled. I will have G1 G2 G3 divided by 1 plus G2 H1 plus G2 G3 H2 plus G1 G2 H1. Okay. Now this entire block is there in the forward path, and if it is a positive feedback, then this has to be a minus. This has to be a minus sign. Like you can see it here, this one G1 G2 G3 divided by 1 plus G2 H1 plus G2 G3 H2 minus G1 G2 H1. Now I can see these two blocks, these two are found to be in uh, parallel. So I can add these two and end up with a equivalent transfer function. The G1 G2 G3 divided by 1 plus G2 H1 plus G2 G3 H2 minus G1 G2 H1 plus the parallel block G4. Thank you.